Hi everyone and welcome back to another episode of Matter for Thought. Today I have the honor to have a good friend on the mic. Vishanti, the stage is all yours.
As mentioned in the previous episode, today we'll dig a little deeper into the quadratic equation. The quadratic equation is also called a second-degree polynomial, and it looks like this. ax squared plus bx plus c equals 0, i.e. some number times x squared plus some number times x plus some number equals 0. In order to understand the geometric meaning of a quadratic equation, we'll first take a look at the line represented by this equation. Y equals ax squared plus bx plus c. This line is a very interesting curved line called a parabola, and it has some properties we won't elaborate for now. In cases where one of the factors is 0, we get much simpler equations. If a equals 0, we get bx equals negative c. And if b equals 0, we get ax squared plus c equals 0. That only requires finding the square root. And if c equals 0, we get x times ax plus b, which is very similar to the first case, but one solution is 0. The quadratic equation actually tries to find when y equals 0, i.e. when there is no height component to the parabola, or, in simpler language, where, that is, for what values of x the parabola intersects the y-axis. Because we're looking for x, let's see what needs to be done to get x alone on one side instead of y on one side. So let's do it together. ax squared plus bx plus c equals 0. Step 1. Subtract c on both sides. ax squared plus bx equals negative c. Step 2. Multiply each side by 4a. 4a squared x squared plus 4abx equals negative 4ac. Step 3. Add b squared to both sides to complete the square. 4a squared x squared plus 4abx plus b squared equals b squared minus 4ac. 2ax plus b squared equals b squared minus 4ac. 2ax plus b equals plus or minus the square root of b squared minus 4ac. Step 5. Subtract b on both sides. 2ax equals negative b plus or minus the square root of b squared minus 4ac. Step 6. Divide by 2a. You're left with the values of x1 and 2 equals negative b plus or minus the square root of b squared minus 4ac over 2a. I suppose most of you know this formula or have come across it at least once before. So now we will try to solve a slightly more complex problem in ballistic motion. We will be left with the same cannon, the same speed, and the same angle, but this time the target is at an altitude of 1,403 meters above the height of the cannon. What is the distance of the target from the cannon? R at t equals 0, 0, plus 400, 300t, plus 0, negative 4.9 t squared, equals an unknown distance, 1,403. In the x-axis, we were left with the same equation from the previous episode, but in this case, the time t will be different. To find what time it is in this problem, we will solve the equation in the y-axis. Negative 4.9 t squared plus 300t plus 0 equals 1,403. Negative 4.9 t squared plus 300t minus 1,403 equals 0. A equals negative 4.9, B equals 300, C equals negative 1,403. X equals negative 300 plus or minus the square root of 300 squared minus 4 times negative 4.9 and 1,403. All over 2 times negative 4. X equals negative 300 plus or minus the square root of 300 squared minus 27,499.8 over negative 9.8. x equals negative 300 plus or minus the square root of 62,500 all over negative 9.8. X equals negative 300 plus or minus 250 all over negative 9.8. X1 equals negative 550 divided by negative 9.8, which equals 56.1. X2 equals negative 50 divided by negative 9.8, which equals 5.1. I've rounded the numbers a little so the results will be nicer. Just like in the previous episode, the shell reaches a height of 1,403 meters the first time shortly after firing, when it is still gaining altitude, and the second time when it is deep on the way down. The first time is not so interesting to us at the moment, although it is mathematically correct, but only in terms of reality. So, if it took the shell 56.1 seconds to reach the target, what is the distance it traveled? As in the previous episode, we will place the time we got in the x-axis equation and get 400 times 56.1 equals 22,440 meters. In the next episode, we will get to know a new concept that unites progress on the x-axis and progress on the y-axis, and we will see what its uses are in relation.
Wow, that was a pure pleasure listening to you. Thank you very much for that. And that's for today, friends. If there is nothing not clear enough, you're more than welcome to contact me, and I'll do my best to answer. Before I wrap things up, I want to thank my patrons. If you find the content good and the cause worthy, link to my Patreon is in the description. If you liked it, hit the thumbs up, share, comment, etc. I was, as always, rndthinker, and see you in the next video.